Okay, so I think we are live. Yeah, cool. I guess we'll wait for a few minutes for people to join in and then we'll get started.
Okay, I think we should start now, Sam.
Oh, are people tuned in already? Like, should we start then?
Yeah, I think we should start. We should start.
Cool. I guess we'll start then. Oh, okay. Chanak is saying Ruko. Wait. Okay, he said okay, cool. Uh,
I think we should start. We should start. I think.
yeah, I guess we'll start. Cool. So, hello guys, a very good evening to all of you. And as a part of the solution challenge by Google Developer Student Clubs, we are conducting a design day, which is a basic workshop and like a three-part bootcamp on what exactly a design sprint is, how UX and product design is very important for any product that you want to develop, and we'll also be hopping on to the technical architecture of the product. So yeah, we'll just quickly introduce ourselves. I am Swayam Sharma, and I am a senior INCO member here in the design team of GDSC VIT.
And I am Hisham Akhtar. I am also a senior Inacol member at the technical team at GDSC. And today we'll be taking a session. So the way the session will go is firstly, Swayam will take you through the product design and everything about UI and UX. And after that is done, I will be taking over and I'll be talking about software design. And we'll be going through several processes in software design and how you can go about taking the design to an actual software. So I think I'll give the stage over to Swayam now. Swayam.
Yeah, sure. Cool. So for this workshop itself, what we've done is we've selected our own problem statement. Like we've chosen a problem statement of a journaling app, and we'll be showing you the whole process of the whole design process, how you like user research is done, all of that, and then we'll be also converting, like showing how technical architecture for the same like demo problem statement is done. So yeah, starting off, we'll be talking about design sprint. So what basically a design sprint is? So there's this wonderful book called Sprint: So How to Solve Big Problems and Test New Ideas in Just 5 Days by Jake Knapp, which was invented at Google, and it's a Google Ventures book. So what it basically it is all about solving new problems and validating your solutions. So it is structured in a 5 day period. And so what all do you do in the 5 days? You understand, map out the problem and pick an important area to focus. Then you ideate and like sketch out the competing solutions on paper. Then you also decide which one of the following solutions that we ideated on is going to be the one which will be going forward with. And then you prototype, and then the final procedure is test. This is an amazing book, and this book is the one which laid foundations for design sprint. A lot of startups all across the world use this process to launch new features to their apps or anything like that. Yeah, so this is a basic diagram which shows how a design sprint works. So as you can see, the week is divided from Monday to Friday. And here it says on Monday we'll be making a map and choosing a target. So you choosing a target means you'll be fixing a problem statement that you want to work on. And then on Tuesday, all the team members will sketch competing solutions. You'll be trying various solutions out. What do you think would work best out? And then on Wednesday, everyone groups together and decides ki, okay, this is the best solution to the problem. And I think we should build on top of this. And then you build a realistic prototype there are various prototyping tools across the internet. Like we'll be also discussing few. So yeah, you prototype the solution and then you test with target customers, and you can just repeat the cycle again. Cool. That was basically how design sprint works. Now we'll jump into user experience. A lot of people say that they are UI UX designers, but it's kind of a shame that a lot of people don't even understand the core values of user experience. You like we'll be seeing how user experience is not just about designing a website or just creating visuals for an app. So, what is user experience design? User experience design encompasses all aspects of the end user's interaction with the company, its services, and its products. And this is the definition given by Don Norman, who is a cognitive scientist, and he is like the father of UX design. He was the one who coined the term user experience in 1990s. So yeah, and what a few points to note down about user experience design would be: it is a process of developing and improving the quality of interaction between a user and all facets of a company. User experience design is in theory a non-digital cognitive science practice, and this is so important. Like it's not just about designing a mobile screen, it's not just about designing a website. It could be designing how a soda vending machine interface works, or how your AC's remote interface is. All of that is human interaction. So anything which regards human interaction is user experience design. And UX design is not about the visuals, as I said. It focuses on the overall feel of the experience. So yeah, it's the UI part which delves into how visually appealing the interface is. So I have a really small and very basic example of differentiating UI and UX, and this is taken from the Bible of UX, which is the design of everyday objects. And this just shows how like a glass tomato ketchup bottle has a better UI. It looks, I say, more expensive, and it looks better, but it is not very usable because you can see the person has to slam around the bottle to get the ketchup out. But UX wise, if you see, the squeezy bottle is so much better, its user experience is better. But although even now there is a big debate about how the user experience of a glass bottle could be better in a longer run, because plastic bottles basically have microplastics, and if you're consuming from them, you're consuming microplastics. So how in a very long run it's harmful for the user, so its user experience is bad. And there's also something called usability. And so what happens is the inverted ketchup bottle gets clogged with tomato ketchup and all that. It's a very like deep topic, but yeah, you get the point to differentiate between UI and UX. Oh, okay. So UX fails. This is one of my, as someone who enjoys memes a lot, this is something I enjoy like going through in my free time. So as you can see, this lift interface is so hard to comprehend. It says G has lobby, reception, and first floor. Like the third floor has fifth floor and all that. So it is a very bad, terrible UX. If I enter into this lift, I'm never getting to my floor. And again, okay, WhatsApp deleted message. WhatsApp in general has amazing UX. A lot of people across the world use it. But this single feature, according to me, is very bad UX. So whenever you delete a message, it shows ki you deleted this message, and this is very counterintuitive to what a user thinks. A user expects that when I delete the message, all history of the message is deleted, but this leaves a message in front of it, and this also might get like suspicious prompts from the person. He might say, okay bro, why did you delete the message and all that. So yeah, that's bad UX. And again, here it says, do you really want to cancel this reservation? Cancel, yes. So okay, I want to cancel. Should I press cancel or should I press yes? So all these are UX plays, and this just shows how important user experience in general life is. Cool. Design process. Now here is, from here onward, the design process starts. So the design process is basically divided into five major steps. It's product definition, research, analysis, design, and then validation. So, what is product definition? One of the most important phases in UX design is actually done before any team creates anything. Before you can build a product, you need to understand the context of for existence. The product definition phase sets the foundation for the final product. During this phase, UX designers brainstorm around the product at the highest level, basically the concept of the product. So, if you've heard about the Kidlin's law, it basically says if the problem statement is laid out 100%, your problem is already 50% solved. So, laying out a clearly stated statement is very important. So, like I said, we'll be using a journaling apps example for our design process. So my problem is currently most journaling apps are more of to-do lists than journals, and they tend to focus more on tasks rather than calendars and planning. Apart from this, these apps also have complex user interfaces with very low usability, and therefore users find it difficult to organize their thoughts since they have to focus more on understanding the UI rather than focusing on their ideas and feelings. So now I have a very clear problem. Ki a lot of apps are more like to-do lists, and I want to create something different which is in line with calendars and planning. Now comes this research phase. Once the idea is completely defined, the product team moves to the research phase. This phase basically includes both user research and market research. Good research informs design decision, and investing in research early on in the process can save a lot of money and time down the road. So, like we can conduct user surveys, which is a method of primary research. Now, okay, a small no, primary research is basically any sort of research that is conducted by my own self. Like it could be an interview, it could be a survey. All of that is primary research. So here we can see in the primary research survey, we see that 30% of the people that we surveyed journal daily, and 40% of them journal monthly. Next, research is competitor analysis. This is a part of secondary research, and secondary research is any sort of research which is done on the basis of research which is already done. Like it could be studying research papers or going through various articles in the internet. So competitive analysis is a very sorry common example, and here I'm comparing a few journaling apps, which is like Day One, Journey, Dailyo, and Grid Diary with the various features that they have. After the research is done, we go to analysis. And the main aim of analysis phase is to draw insights from the data that we collected in the research phase, and moving from what users want to why do they want it. In this phase of UX process, usually includes creating user personas, user stories, and storyboarding. So these are like examples of how this is an example of a user persona where we have a hypothetical person called Mary Jane, and her pain points are crowded screen, bad color palettes, and not enough editing freedom within calendars. So this is a user persona regarding our journaling app, and this is just a random storyboard. It shows how storyboards are in general created. This telling a story through your designs is a very important skill to have, and like many people have said it, behind every good design there is a very good story. So if you show that story out to the people around you, it creates more impact. Now, this is the part when you finally start designing. Designing is like the fourth step. When users' wants, needs, and all the expectations from the product are clear, product designers move to the design phase. At this step, product teams work on various activities from creating information architecture to the actual UI design. And this is where UI designers step in, where they create visuals for the screen. The design phase usually includes sketching, creating wireframes, and creating prototypes. So I created a very rough wireframe for our journaling app, and as you can see, this is very rough. But this just gives me an idea of how my home page is going to look like, and how I'm going to have like a calendar page next to it, and how I'm going to have more all journals page and all that stuff. So creating a like sketching out your wireframes is very efficient, and it helps you save a lot of time and energy. Yeah, so this is after creating your like low. So in general, wireframes are called low fi designs or low fidelity designs, And after your low fidelity designs are done, you move on to high fidelity designs, which is hi-fi design. And like I created these in Figma, but you can use any software like Figma, Adobe XD, and this is basically a prototype, which where I can see for my journaling app, I have like a small motivational quote which helps you become better every day, and it has a monthly calendar, so it shows March 2022, which is the current month. And then we have recents, which shows the recent journals that I created. And then I have like the calendar part where I can just go to any date and I can see if there is a journal on that date, or if I want to create a particular journal for a very past date, I can quickly do that through the calendar page. And then I have like a all journals page. This just shows all the journals that I have created till date. And this also has a search bar, and how searching works will be amazingly explained by Hisham soon. And this also has like a small sorting feature. So yeah, this is the hi-fi designs. And after these designs can be easily shared with your friends or anyone that you know, and you could test these design in the validation phase. Validation is an essential step in the design process because it helps teams understand whether their design works for their users. Usually the validation phase starts after the high fidelity design is already done, since testing with high fidelity designs provides more valuable feedback from end users. And we can do validation by analytics. We can just see how many clicks I'm getting every minute for the CTA. Are people able to figure out which is the main CTA, which is the secondary CTA? We can do surveys. We can share these design and surveys and ask people how are they liking it, do they have any problems? Or we can do testing among people, like we can ask them to test it for ourselves. So this generally covers the complete design process. And once you're done with testing, you'll get a lot of feedback, and you again start working on the feedback. You research key, okay, why are people having this problem? And then you again analyze it and you design new solutions to that. And that's exactly how design is done. It's a lot of reiteration, and that improves your design a lot. Now, I think we'll be moving on to how the design that I created can be converted into actual apps. So, and that is software design or technical architecture. And Hisham will be taking the stage now. Hisham, you're on mute.
Oh, I'm sorry. I'm sorry. So thank you,
Yeah.
Sam, for that amazing session on design. I think we can move to the software design part now. So I hope my screen is visible. So I'll start now. Right. So let's talk about software design, right? So earlier you saw how the app was actually sort of ideated and how people sort of made a prototype out of it in some software like Figma, right? But that is something that is not usable for the end user, right? In an application, you need to sort of have the code written, and it it has to be such that every user can sort of use it, install it on their phone, and use that app, right? So that is where software design comes in. So obviously whenever you are making a software, there are two phases in it. There's software design and there's software development, right? So the software development part is where you write the code. So the code, I mean, whatever, you can write in any language or whatever and everything, and you develop the application and you have software engineers and everything. So that is the software development. But before you do that, before software development even starts, software design has to be done. You need to understand how the different components of the software is working, and which component is supposed to do what task, and what are you using to build each of those components. All of that is very essential to understand. Otherwise, software development, which is the next step, is going to be a disaster, right? So the first thing that you need to understand is what are the different parts of the software that you're going to build, right? So I have a simple diagram here. I will just enable my pointer. Right. So we have the app, we have the backend, and we have the database, and we'll be going through each of these one by one as to what each of these mean. But anyone who is in layman's terms, this app is what you install in your phone, and this thing, backend and database, this is somewhere else. It's located somewhere else, and you have to basically build all of these three. All of these three together will form your software. Just making the app and without the backend and database will not work, right? Or just the backend without the app or database will not be sufficient. And each of those have to communicate with each other so that all of this comes together, right? So this is a really really simple architecture, right? There could be a lot more components in this. This backend could not just be one. This could be like multiple backends, and there could be multiple databases, right? This app could be of different versions for different sort of users and all of those. So this is like a really basic overview, right? So we'll go through each of these one by one, and we'll try to understand how you can build each of these. I'll give you some sort of most commonly used frameworks and all of that, and then we will just take a look at a general app, and we'll look at one screen and how we can take that one screen and we can break down the features of each screen into these three different parts, right? So the first thing is the app, right? So this is a question that I was very intrigued with when I came into college, and that was that how is the app really made? I mean, the only sort of coding that I had done by that time was basically coding up algorithms. So what is it that I could do that the code that I was writing in Java or C++ could actually be taken and put into a real life application which I could use, right? So there are several frameworks present, obviously. So the two major mobile phone operating systems are Android and iOS, right? I mean, 99.99% of the population uses either Android or iOS. So for each of these Android and iOS, there are native frameworks to build apps for them. So Android has native Android can be used and can be built using Kotlin or Java, and native iOS can be using Objective C or Swift, right? However, there are also other frameworks like Flutter and React Native. Flutter was developed at Google, React Native was developed at Facebook, and these two are also really amazing frameworks. And using these frameworks, you can basically build cross-platform applications. So the application will work on Android as well as iOS, right? So these are also very useful. So now, whenever you are making an app, you have to take a very essential decision, and that is whether you have to use Android, iOS, Flutter, or React Native, or any other. There are other frameworks as well, right? These are not the only four frameworks present in the market. There are like a lot more, right? These are the four major ones that I know about. Just one second. I am sorry. Uh, so yeah, so these are the four major frameworks that are present in today's market, right? And you have to decide which one of these you have to use. So to do that, you have to take the decision whether you are targeting only Android or if you are targeting only iOS, right? If that is the case, then maybe going with the native one is good, right? Then you have to decide that how big your application is and whether the cross-platform ones would be able to support those big applications or not if you are targeting both of them, right? So there are a lot of design decisions that are included, and you should go through each of these. So I could basically take a one whole session on each of these, right, and the pros and cons of each. So it is up to you. You have to do your research, and then you have to go ahead. I'm really sorry. Just yeah, thank you. Yeah, so these are the four major decisions that you have to these are the four major frameworks, and you have to take decision based on those, right? So now this is all about the app, right? So now we'll go about where does backend come in, right? So this is our app, and it is very obvious what an app is to all of us. You know, WhatsApp, ev- Twitter, Facebook, whatever you use, all of those are apps, right? But where does that backend come in? We talked about the backend component, right, in this architecture diagram. So where does that come in? So there are several scenarios where a backend is absolutely necessary, and uh, the thing is, I have listed down three which I could think of, but there can be many more cases when a backend is like really really necessary and you cannot work with just the app, right? So the first thing is when the data has to be persisted across devices. This is pretty simple to understand. You could think that suppose I have a journaling app, right? That's what we are talking about. So my journaling app, I wouldn't want to lose all my journals if I switched phones, right? If I switched phones, I wouldn't want to lose all the journals that I had created over the last 5 years. So that data has to be stored somewhere outside my phone so that it can be retrieved from that place all the time. That is where the backend can come in. When data has to be persisted, or suppose there's some sort of computation that has to be performed and that needs a lot of resources, right? So your phone is a really small device and it cannot perform very huge computations. So if there's a computation that is really huge, and that should be performed in the backend and not on the app itself. Then the third is that the data that you're dealing with is so big that you cannot just keep all the data on the phone, right? Only a small amount of the data has to be fetched, and the other data cannot be kept on the phone, right? So something like this could, an example of this could be like Google itself. So Google has so much data, right? So you can't store all the data in your Chrome or Google app, right? That has to be there somewhere in the backend, and data has to be fetched accordingly. Whatever we query, that sort of data is fetched for us and stored on our device and shown to us. So these are three examples where a backend can come in, but there can be like many more examples, like chatting and real time stuff and video calls and all of those. When two users are connecting to each other, then only the app will not work and everything. So there are too many of these sort of scenarios where the backend will come in. So what are the most commonly used backend frameworks? These are four. Apart from these, there's like way too many backend frameworks available. You can use any of them with any of these app frameworks. Any of these app frameworks can be used with any of these. These are completely independent of each other. These are for four popular ones. So Django is using Python. Spring Boot is using Java, Node and Express is using JavaScript, as the name says, and Golang is a programming language that itself, using its native libraries, you can build backends, and also you could use a lot of other things as well in this, right? So these are four commonly used frameworks, right? So these are the four backend frameworks, and each of them have their own advantages and disadvantages. And when you are, again, this software design part would be choosing which one is good for you. I mean, so if what you're making needs very low latency, then using Golang is good. If what you're using needs a lot of real time application, then maybe Node.js is good, right? So all of these frameworks have their own pros and cons, and it is very essential for you to choose what is correct for your particular application. If I was asked personally what I would use for this journaling app, I would go with Flutter for the app, and I would go for either Node.js or Go or Spring Boot for the backend, right? So how do the backend and app communicate with each other, right? So you see these arrows. So how does this happen? Backend and database can communicate with each other that without any issues, but how does, because they are like located at the same place, right? Because the backend and database, they'll be like at the same place. But then how are the app and backend going to talk to each other, right? Because the backend is going to be in somewhere, some server in USA or something, and the app is being used by people in India and China and Europe and everywhere. So how does that work, right? So the simple answer is APIs. This is a term that you will see thrown around a lot. The simple term is API, or Application Programming Interface, and uh, the basic work of APIs is to help app and backend talk to each other, right? So these are the two main. This is the main work of this API. These arrows are actually the API. So the app will request for something, and the backend will send it back. So that is what an API is, right? And the third component, of course, is the database. So the database, now, as the name says, I mean database. So where all the data is stored, where all the journals will be stored, where all the user data will be stored, all of those will be in a database, right? And these databases are and you get a lot of pre-built, really, really good software solutions out there for these databases. So one is Postgres, MongoDB, MySQL, and everything. And I could probably take like 10 sessions on databases. I mean, databases is such a huge topic, right? So I can't go into the intricate details of everything about databases today, but these are three common databases that are available, and there are several more apart from this as well, like Cassandra, HBase, and everything. There's something called big data databases and all of those. So these are the three main databases available that I have put, and these are the ones I'm comfortable to use. So so for me, if you would ask me what I would use for the journaling app, I would probably go with uh, Flutter for the app. I would probably go with Spring or Node for the backend, and for the database, I would probably go with Postgres or MySQL. But again, it depends on you. And each of these frameworks are independent of each other. So you could easily use Postgres with any of these four, and you could use any of these four with any of this, right? So these are components that don't depend on each other, really. So if someone asks you, can you use Node with MySQL? Of course you can. So if someone asks you, can you use Django with uh, MySQL? Of course you can, right? So these are independent of each other. So right. So this is all about databases and backend and app. So I think I've explained to you the three things that will be involved in the software design of anything like a journaling app, right? Now let's just talk about the journaling app itself, right? So this is one screen, so we'll just go into depth about one screen, right? But the same sort of thought process can be applied to all the other screens as well. So The first thing that we need to understand is what are the different parts in the application that has to be implemented by the front end app, and which parts have to be implemented by the back end, right? So the parts that have to be implemented by the front end, I've written down 3 points here. The first thing is displaying the data, right? So you see this: I got a new doggo, Kanha National Park, Kolkata Trip Journal, Kerala Trip Journal, I fell in the pool. These are all journals, right? And this is all the data that is present in here. So these have to be displayed, right? These have to be displayed, and this displaying, and how it will look, and what is the color of this, and all of that, that is the function of the app. All that has to be implemented in the app itself. The second thing is, of course, handling user clicks. So if a user clicks and starts searching, so that handling those clicks on the screen, that is a function of the app. Some of the user click handling is done by the OS, and some of it is done by the app. And it is not just limited to clicks; it could be some sort of gesture also, like swiping or something like that, right? So all of that has to be handled by the app. Some of those are handled by the operating system itself. For example, you could see that there are generally three buttons at the bottom, and there are some gestures which you could go back. So those may be handled by operating systems, but in general, the interaction that happens with your app, that has to be implemented and coded out in the app, right? So that is one thing. The third is calling the new backend for new data and creation and everything. So suppose I want to create a new journal, right? So the backend has to be called, right? So that calling the backend for like fetching the data or creating a new data or searching on the data, that is the function of this application, the front end application, right? So now what is the function of the backend? Right, the function of the backend is to firstly sort of, whenever the front end asks for any journals, right? So this is basically lists all the journals of the front end based on the date, right? So this is something that the backend has to send to the front end, and the front end can simply display it. So the sorting of these journals, on which base it is sorted and everything. So right now you could see, I think this is sorted based on the date, right? So the backend has to sort the data. Backend has to basically fetch the data from the database, sort it, and then send it to the app whenever the app is asking for it. So this is something that is done in the backend, right? Secondly, creating a new journal. Of course, if someone wants to create a new journal, so they just click on this create button, add whatever the details they want to add, right? And then uh, when they hit create, so that backend has to will get the request, and that the backend will sort of take the data that has come from the app, and will put it into the database, and that way it will be able to create the data in the database, right? And the third thing is, this is something that I wrote as a separate point because I want to speak a teeny bit about it, and that is searching. So suppose I want to search through this journal. So how do I do that? That is also something that can be done on the app and the backend itself. But doing it on the backend provides a lot of functionality to you that could not have been done in the app, right? And that brings me to my bonus part. So how do you work with search, right? So searching among data is something that happens all the time, right? Almost every third app I open, there is some place where I will be searching for stuff, right? So if I open something like Google, I'm searching on Google, right? If I open something like Google Keep, I can search among my notes or whatever. So all that is, so searching is implemented everywhere, right? And there are lots of ways to search through your data. The two very good solutions for searching is Algolia and Elasticsearch, and these are actually components that are very different from app backend and database. These stand somewhere between the backend and the database, right? So there's something that is sort of a bonus thing that I'm telling you. So Algolia is a software, it is a company, and if you want to use Algolia, it is paid and you have to pay money to use Algolia. But Elasticsearch is free. Elastic is also a company, but it is a open and free software, and you can use Elasticsearch as and when you want, right? And this search part actually deals with very sort of intricate things, right? So suppose you want to search for the journal I got a new doggo, right? So you type dog, right? So if you just type dog, it should identify that dog is a part of the journal I got a new doggo, and it should put that journal on the front for you when you are searching, right? So that sort of deciding which one is relevant to the search query that has come in what order should the search queries be ranked, and of those are very complicated processes, right? And there's like a lot of research being done on those things. So searching is something that is becoming very sort of relevant. That is why I thought I'll include it in here. So that all that process, right, that has to be done using the search. It can be done easily using Algolia or Elasticsearch itself. and these are very very good extensible software that you could use, right? So this is all about the search and software design and everything. I think I have given you a good overview of how you could take the design and understand the different components that are present in a software and how you could go about sort of building those, right? So I guess I guess we are coming towards the end of our session, right? So we talked about. I'll just do a small recap of what all we did. So first we talked about app, then we talked about backend, then we talked about databases, and then we just broke down one screen. I think Sam showed you like three, four screens, right, for this journaling app. So each of these screens have to be broken down, and you have to understand what has to be done in the app, what has to be done in the backend, and how you can make the app and backend, what are the frameworks available, and all of those, and how you should be thinking to as to which framework you should be using in your application. So uh, is that is something that I have tried to convey to you, and what are the uses of each and everything. So I think we have come to an end now. So I'll say thank you. We have come to the end of our solution challenge design session. The last thing that I'd like to say is that solution challenge is an amazing opportunity, and I think that all of you should essentially register for solutions challenge. Try to give in any sort of solutions that you can come up with, because this is a very good opportunity for people to sort of network all over the world and present their talents in front of a very huge judge, right? So thank you so
Yeah.
much. I think Sam, do you have anything else to add, Sam?
No, I don't have anything else to add, but I think we could take a few questions if there are any in the chat. So if you guys have any sort of questions regarding design or any like software design, anything, so we're here for you.
Let me just open the live stream on my phone so I can easily check
Yeah.
out. If there's any questions, we are free to take all your questions. Okay. I don't think we have any questions yet,
Yeah.
Sam.
Yeah. I guess yeah we don't have any questions yet. So yeah, I guess
Can you
like in
give
general
okay,
this.
we have some questions, Sam. So Dinesh
Oh,
Kanam
that's
says, can
nice.
you give some examples on API? Okay, as I told you, API is basically API is when your front end needs to interact with your back end. So they do that through an API, right? There is no example that I can give you an API. API is something that you will be building. Many a times you will find that there are third-party backends that have already been built for you that you can use in some cases. So those cases can be like, you could say API. So there's the Google Maps API, right? So if you want to use Google Maps in your app, you could use the Google Map API to work with it, right? But at the end of the day, it is all about interact, making your front end interact with your back end, right? Any other question? I don't think we have any questions, so we
Yeah.
can stop now, I guess.
Yeah.
So thank
Just
you,
one
guys.
last thing from my side, I think. In general, this was a very short and informative session, but I think you guys should go and do your homework and like dive deeper into these concepts of product design, of how research is done, all of that. I just showed you how the basic processes, but you should go read up books or maybe blogs available on Medium, and that's how you gain more knowledge. So yeah.
Yeah, exactly. I would definitely agree with Sam on that. That this is something that we've tried to give an introduction to, but you have to go and you have to do your own research, and then you can work with it and make your own solution for the solutions challenge.
Yes. Cool. I guess we'll just wrap it up then. Uh, Thank you for joining in. And this is Hisham, so I'm signing off. Bye. Peace.